Hello students, welcome to Teachusmart. Let's continue our journey through polynomials. Here, we can see a basket. Something is hidden in the basket. Let's check. What's in it? Yes, some polynomials are hidden in the basket. Let's take them out. X squared plus 5, 2x minus 9, 4x cubed minus 3x plus 1, 5 plus 7x, and y squared plus y plus 1. See, these are the polynomials, having different degrees. We can classify them based on their degrees. So let's classify them as linear polynomial, quadratic polynomial, and cubic polynomial. The polynomials 2x minus 9 and 5 plus 7x are first-degree polynomials, hence called linear polynomials. X squared plus 5 and y squared plus y plus 1 are second-degree polynomials, hence called quadratic polynomials. 4x cubed minus 3x plus 1, a third-degree polynomial, and is called cubic polynomial. Today, let's learn the number of zeros of a polynomial. Let's see it through an example. Find the zero of the polynomial p of x equals 2x minus 9. We know that the zero of a polynomial is the value of the variable for which it becomes 0. That is, to find the zero of a polynomial, equate that polynomial to 0. So here, equate p of x to 0, which implies 2x minus 9 is equal to 0. That is, 2x equals 9, or x equals 9 by 2. Therefore, x equals 9 by 2 is the zero of the polynomial p of x equals 2x minus 9. Consider another example. Find the zero of the polynomial p of y equals 5 plus 7y. To find the zero of p of y, equate p of y to 0, which implies 5 plus 7y equals 0. That is, 7y equals minus 5, or y equals minus 5 by 7. Therefore, y equals minus 5 by 7 is the zero of the polynomial p of y equals 5 plus 7y. By observing these two examples, we can see that both polynomials are linear, and there is only one zero for each polynomials. That is, a linear polynomial has one and only one zero. In general, for finding the zero of a linear polynomial, p of x equals ax plus b, where a is not equal to 0, we equate p of x to 0. That is, ax plus b equals 0, implies that ax equals minus b, or x equals minus b by a. That is, x equals minus b by a is zero of the linear polynomial p of x equals ax plus b, where a is the coefficient of x and b is the constant term. Or, we can say x equals minus constant term divided by coefficient of x. We just need to write x equals minus b by a. Now, let's find the zeros of quadratic polynomial p of x equals x squared minus x. To find the zero of p of x, equate p of x to 0. That is, x squared minus x equals 0. Taking x as common, we can write x multiplied by x minus 1 equals 0. We know that product of two factors is equal to 0 means each can be 0. That is, x equals 0 or x minus 1 equals 0, which implies x equals 0 or x equals 1. Now, we have seen that for a quadratic polynomial, there are two zeros. Similarly, find the zeros of a cubic polynomial, p of x equals x cubed minus x. To find the zero of p of x, equate p of x to 0. That is, x cubed minus x equals 0, which implies x multiplied by x squared minus 1 equals 0. Since x squared minus 1 is of the form a squared minus b squared, we get the factors as a plus b multiplied by a minus b. That is, x squared minus 1 equals x plus 1 multiplied by x minus 1. Therefore, we can write it as x multiplied by x plus 1 multiplied by x minus 1 equals 0. We know that the product of three factors is equal to 0 means each can be 0. That is, x equals 0 or x plus 1 equals 0 or x minus 1 equals 0, which implies x equals 0 or x equals minus 1 or x equals 1. Now, we get three zeros for the cubic polynomial, p of x equals x cubed minus x. That is, for a cubic polynomial, there are three zeros. Now, we have seen that a linear polynomial has one and only one zero. That means first-degree polynomial has only one zero. Similarly, a second-degree polynomial or quadratic polynomial has two zeros. A third-degree polynomial or cubic polynomial has three zeros, and so on. That is, the number of zeros of a polynomial depends on the degree of polynomial. We will look at more examples of how to find the zeros of a quadratic polynomial and cubic polynomial in coming sessions. Now, let's look at more examples of finding the zero of linear polynomial. Find the zero of the polynomial p of x equals 4x plus 3. For a polynomial ax plus b, 0 is x equals minus b by a. In the polynomial p of x equals 4x plus 3, the value of a is 4 and value of b is 3. Therefore, 0 of p of x is x equals minus b by a equals minus 3 by 4. That is, 0 of p of x equals 4x plus 3 is x equals minus 3 by 4. Let's do another example. What will be the zero of linear polynomial p of x equals 8x minus 1? For a polynomial ax plus b, 0 is x equals minus b by a. In the polynomial p of x equals 8x minus 1, the value of a is 8 and b is minus 1. Therefore, 0 of p of x is x equals minus b by a equals minus of minus 1 by 8 equals 1 by 8. That is, 0 of p of x equals 8x minus 1 is x equals 1 by 8. Let's recall what we discussed today. Today we discussed number of zeros of a polynomial depends on the degree of polynomial, and 0 of a linear polynomial, p of x, equals ax plus b. Before winding up, let's check how much you understood by doing an activity. Find the 0 of the polynomials in each of the following cases. 1. P of x equals minus 2x plus 1. 2. P of x equals 3x plus 2. 3. P of y equals 7y. 4. P of y equals 12y minus 9. That's all for now. See you all in the next class.